back to my science world. Science vlog as usual. Go back to business mga kapatid. Okay? Like that. Okay. So we need to introduce to you some basic equations in relation to thermochemistry and thermodynamics. Okay? So you know the difference is very small between thermochemistry and thermodynamics. Okay? Thermochemistry and thermodynamics versus, let's have this versus thermodynamics. Okay? Dynamics. Okay, in the first term, thermochemistry, it involves a lot of chemical reactions. Chemical reactions. Okay, chemical equations like that. Chemical bonding like this. Chemical bonding. Okay, like this. And thermodynamics involves a lot of, a lot of systems. Open system, isolated system like that. Okay, closed system. Okay, and then the matter and energy will be interactive. Matter and energy, meaning to say there's motion. You know motion? What is a motion, Sister Terry? Okay, motion. Okay. Okay, motion. Motion means any particle or object that moves to a particular distance with a particular speed. That's motion. Okay? There's speed at a particular distance, like that, and then dependent in time. Okay, that's motion all about. Okay? So it means to say that motion is general term referring to speed, distance, and time. So that's my own definition of motion. Actually, that is not in the book. That's how I interpreted motion really is. Okay, by extracting the three scalar quantities, the distance, the time, the speed. Okay? So in physics, guys, speed is also known as the rate of change of the displacement. No, the distance only. The rate of change of distance, like that. And then, we have also the distance. Gilipin na ako gamay ang physics technology. Okay, the rate of change of distance. And then we speak about velocity, the rate of change of displacement. Okay, displacement. So displacement and distance have little difference. Because distance you will add 1, 2, even 2 that's already zigzag. Okay, but displacement, you will refer only to the initial point plus the last point. And the middle distance covered will no longer matter. Okay, the final destination and the initial destination. Something like that. And the source and the final displacement. Okay, but distance you will add 1, 2, 3, 4, even though that is zigzag, going there, going to that, going to the left, like that. Okay? Get the point? I'm going to show you the mga kapatid. Okay. So that's motion. If there is motion, so an object or a particle is moving, meaning mobile, M-O-B-I-L-E, mobile, or mobile. So once it is mobile and mobile, that is moving, okay, meaning to say that is dynamic. Okay, dynamic. Because it is moving. Okay, dynamic meaning, for example, if you are a singer, you have a good dynamics of your voice. You need to slow to fast, to slow to fast, from soft to hard. So your voice like this, like that. So it's gonna be like that also dynamics. Okay? And that is thermo, meaning the dynamics of heat, not the voice. Okay? So thermodynamics. You get the point? So it's gonna be like that in interpreting in a correct way of the terminology first so that we can understand what context and subject we are studying with. Okay, thermochemistry versus thermodynamics. Okay. Now, Kita point ma? Dito mag-solve guys, theory lang sa. Okay? Okay, thermochemistry involves thermochemical equations. What are thermochemical equations? Guys, what do you mean by thermochemical equations? Okay, a chemical equation that involves enthalpy change of reaction. Okay, like that. So thermochemical equation is a chemical equation that involves enthalpy change of reaction or heat of reaction, like that. Because as I told you earlier, thermo means heat, and then thermochemical equation. It's just only a combination of the term chemical and the thermo. Oh, okay, you get the point. Okay, like that. Okay, so for example, if I have here, what is your favorite chemical reaction? Me, I like water. It's the simplest chemical reaction in the planet Earth. So H2 plus O2 is equals to H2O like that, and then 2 like that, blah, 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 so like this. Okay? So this is water. Ganon. Okay. So, for example, if the problem or the paragraph or statement, a particular problem will state only delta H equal to negative, let's say, 241, something like this, kilojoules per mole, like this. So, this is an example of a thermochemical equation. Okay? Like that. Okay, so meaning to say, this negative 241 kilojoules per mole, okay, will be distributed to hydrogen gas, oxygen gas, and water based on the stoichiometric relationship to the number of moles. Okay, so if I will say, what heat energy hydrogen gas produced in this chemical equation? So you will start with 2 moles. So 2 moles of hydrogen gas times 241 kilojoules per mole, cancel the mole, and this is the heat energy, 241 times 2. So heat energy or enthalpy rate of reaction, enthalpy of reaction for hydrogen gas, things like that. Okay? So this is thermochemical equation. Okay? Another example also for this, guys. This is number 1 for thermochemical equation. Number 2 example is the Hess law. Hess law meaning constant heat of summation. Ganon. So the only difference, the constant heat of summation is there's a lot of delta H2 by 2. For example, delta H1, delta H2, delta H3, and you can really observe that the equations are more than 2, not only 1. Okay? More than 2. Equation 1, equation 2, the delta H will be delta H1, delta H2, or ganon. Okay? So that is your Hess law. And then you have to reverse like that and change the delta H of the first equation like that. So that is Hess law of constitutive summation. Now, number 3, this is number 2, right? Number 1 is the basic thermochemical equation, basic siya. 1 equation lang. Okay, in which delta H isa lang kabuo. Diba? And number 3, we have the heat of reaction or standard heat of reaction. Okay? So if we have heat of reaction, we have the standard heat of reaction. Standard na yung mga lingin-lingin sa tumoy. Okay, for example, this one, delta H R. There's a circle at the top that is standard heat of reaction. And if there's no circle at the top, it's delta heat of reaction only. Now, the delta heat of reaction is also known as enthalpy change of reaction. Another term for this, enthalpy change of reaction. Okay. Change of reaction. In most examination problems, they will use enthalpy change of reaction rather than heat of reaction. But what I emphasize is just the same. Okay? Like that. Okay, so what is example for this? For example, if we have one reaction. Okay, one reaction. But there's a lot of delta H. in it. But not necessarily you have equation 1, equation 2, equation 3. Only one equation. Ammonia, NH2 plus H2 is equals to ammonia, like that. So there will be a delta H of ammonia, there will be a delta H of N2, there will be a delta H of H2, like that. And you will add that somewhere along the way, in which equal to like this. Enthalpy change of reaction is equal to the enthalpy change of the product minus the enthalpy change of the reactant. So that is for the third mode. Okay, the fourth. Take note, enthalpy change of the product minus enthalpy change of the reactant is equal to the enthalpy change of your chemical reaction or overall chemical reaction. It should be also stated this way. Okay, heat of reaction of your product minus heat reaction of your reactant is equal to your heat of your overall chemical reaction. So another version. But the word enthalpy is more popular rather than using only heat. Okay, but sometimes due to would like to trick you out, that's why they change the statement. Okay, like that. So number 4. So we have this enthalpy change of formation. Okay, and enthalpy change of combustion, like that. Okay, enthalpy change of formation, take note, reverse na siya. So enthalpy change of formation of the reaction is equal to the change of the enthalpy of the formation of the reactant na siya minus the enthalpy change of reaction of the product. Take note, be careful. In the enthalpy of formation and enthalpy of combustion, the reactant must go first before subtraction, not the product. But in the enthalpy change of reaction, it's always the product will be minus to the reactant. Why it's gonna be like that for the 4 and 5? Because we account the average bond dissociation energies. Okay? Meaning the bond to bond, delta H. You will use the bond to bond delta H. For example, methane, carbon, hydrogen bond. Like that. Pila and delta H. How much is the delta H of reaction for that? For example, water, H2H, hydroxide, O2H, pila ang value niya. If there's no like that, you will most likely go to number 3. Okay? If there's no bond-to-bond value of delta H, you have to analyze the modes, how it will be presented, so that you will not be confused from this 1, 2, 3, 4, 5. Okay? Like that. Okay. Now for the basic thermochemical equation, you can solve this directly through the dimensional analysis from way of solving. Dimensional analysis. Okay, meaning conversion way of solving. Meaning to say, you have the basis of calculation. Take note, only one delta H will be presented there, huh? Only one delta H really, no other. Only one delta H. So that delta H will be for the reactants, for the products. And you will convert from gram to mole to heat, gram to mole, like that. Okay, so that's your identification. Then if the problem will have only one delta H, oh my gosh, this is only thermochemical equation. Like that. Okay, you have an idea already. So it's easy. So first, go to your basis of calculation and then convert that to molar mass, and after that, stoichiometric moles, and then go to heat or reverse. Heat first, going to the molar mass, going to the okay? Like that. So these are all thermochemistry. Okay? Thermochemistry. So in short, electrochemistry is under only thermochemistry. We have also electrochemistry, meaning to say, using chemical reactions to produce electricity. That's the definition of electrochemistry. You need to have the chemical reactions in order electrical energy will be produced or electricity will be produced. So the flow of electrons will be produced through reacting different chemicals or different substances, something like that. Not a battery, chemical reactions. Okay, so voltaic cell or battery is another also example of electrochemistry, right? But this another version by adding really the chemicals. Okay, like that. Now, maghimog na po mo, kailangan po siya electrolysis. Okay, electrolysis, as simple as that, you have to add water. Okay, you have to add water. so that it will be electrolysis. Okay? Water. Why you have to add water? Because the lysis there, sorry, electrolysis. Okay, electro means electric current, electric energy, electricity, or electrons flow. That's for the electro term. And then add lysis. The lysis is the last term of hydrolysis. It was just cut off. The hydro was being removed, the lysis written and add to the electro. That's why electrolysis. Meaning to say there's always water. Because hydrolysis reaction is the reaction of salt and water to produce acid and a base. Meaning to say there's water. Okay? And then salt like that. Okay? You get the point? It was just changed to electrolysis because you are dealing with current. Okay? You are not dealing with normal chemical reactions that involves water. Because if you are dealing only with the macromolecules, it doesn't involve electricity, that would be hydrolysis lang siya. But then you are applying electricity, okay, and electrical energy, that would become now electrolysis. Okay? But still salt or electrolyte plus water, okay, to produce electricity. Something that is electrolysis. Electrolysis under electrochemistry, okay, and electrochemistry and electrolysis is under thermochemistry. Okay, get the point? So meaning to say, thermal energy and electrical energy is always related to each other. Thermal energy, electrical energy are always related to each other. What is thermal energy? Meaning heat energy. Okay? So kuyog niya ang thermal energy, heat energy, o ang electrical energy. That's why we have the term thermal conductivity. Okay, you get the point. So the more the metals and elements has higher thermal conductivity, meaning the more it will conduct to electricity. Okay? Because that's electrical energy. Okay, and you have also to be alert and smart enough to determine the formula of thermal conductivity. Okay, to relate that also with the equations of the Ohm's law. You have to derive another formula for that, so then you can get another formula also. You don't have to memorize class. Okay? As long as you have basic equations, correlate that with the general equation, and create your own derived equations out from that. And then compare that to the books. Okay? And make that as a habit, as an attitude when you are still in high school. And then first year college, second year college, bingo, you will pass really different examinations in your whole life. Okay? Especially in science, math, and engineering. Okay? Get the point. Muna siya ang buhaton. Okay? So, classroom instruction study, self-study, library study. Library talaga. Okay. Kapaloka. So, muna siya. Now, thermodynamics. Okay, because we're done with thermochemistry. I said a while ago, thermochemistry versus thermodynamics, right? Okay, thermodynamics. Okay, like that. So we need to remember the thermal conductivity. The unit of thermal conductivity is, sa ganito, physics, mga palangga. Physics. The heat transfer through conduction. If you remember, if you are working in the insulation industry, in which you are very particular to the outside diameter, inside diameter of the insulation, the heat transfer will be applied there is the heat transfer through conduction, insulation. Okay, like that. You get the point? And then you will have watts per meter Kelvin. Like this is the unit of thermal conductivity. Ha! Take note, there's watts. Meaning to say, it's related to electrical energy. Because watts is the usual unit of electrical energy. You get the point? Which is joules per second. Okay, like that. And then 1 horsepower is equal to 746 watts. Okay, you can convert this to Newton also because joules is in Newton meter. Okay, and then bingo, you can convert that to calorie, and body, you can convert that to British thermal unit. Okay, it's the unit also of heat. You get the point? Why? Because metals or elements, properties, physical properties are usually heat and electricity. Okay? They have the ability to conduct heat and the ability to conduct electricity. So they are conductive to the two physical quantities, heat and electricity. Okay? Ganon. Ito po yung mga palangga. Okay. Now, sinurasa lang natin. Guys. Okay na siya. So, nakakaloka. So, energies ng thermodynamics ngayon, no? So, naman mga energy, chupa-chuchu, ganun, matter, ganun, chupa-chuchu. Okay, the matter part, guys, is involving chemical reaction. A little bit lang siya. Mga phase change, chupa-chuchu. Okay, you know what phase change? PHASE. For example, liquid water will change to vapor water. Meaning it doesn't involve chemical reaction, but the phase only changing. Melting from liquid, from solid to liquid. Evaporation from liquid to gas. Sublimation, like that, blah blah blah, so and so. Okay, condensation from gas to liquid. Sublimation, solid to gas. Gas to solid, what's that? Deposition or de-sublimation. It talks about like that. You can apply that also to thermodynamics. And then apply the energies to the chuchu. Now, energy is equals to heat plus work. Like that. Okay? Meaning to say, you can apply the phase change only to this equation, not necessarily chemical equation. But sometimes also, they will put the chemical reaction and apply this in the delta EQ plus W. Okay? Naranan mo sa iyong baton. Makasabot na ganito na yung mga equation. Yung muli nag-i-relate ano niya, bingo, kuha niya ka sa answer. Okay, ganon. Okay, mga palangga. Okay, now, in this equation, a lot of equations can be obtained. Why I tell you that one? Because delta E is internal energy. Okay, internal energy or external energy or internal energy means the capacity to do work. If you remember the definition in your high school days, that is the common definition of an energy, is the ability or the capacity to do work, right? Since the work also has its own definition, right? Work is the applied force with its covered distance. Okay, so force times distance, like that. Okay. Since your energy unit is, let's say, joules, calorie, like that. Your work also unit will be joules and calorie, dependent with each other. Okay? Get the point? Talaga mo na siya metabo. Okay. Why? Because also, charara, in dealing with mga motion, chuba-chucho, okay, mga speed, velocity, wala naman siya nag-involve of heat. So the heat will be zero. If heat will be zero, not included in your system, the delta E will just equal to be your work. That's why their unit will be the same. Okay? So all your energy will be converted to work. Something like that. In this situation, this is now a diabatic thermodynamic process, meaning constant heat, or there's no heat exchange, zero in the process. Heat is equal to zero. Okay? Like that. So all your energy will be converted to work because there's no heat energy involved, something like that. Okay, so normally this can be delivered through machine, right? You get the point? Ganon. And then there's a lot of Q also here. Kakaloka. As I discussed you yesterday, there are 12 equations, okay, related to heat energy. And then substitute that here also. Then you can find another formula also without referring the book. Get the point? I'm teaching you not to be bookish. Okay? Like that. That we can create our own formulas and equations through correlation and linkage of different basic formulas and connecting the dots, and you can derive your own formula. So this is going to be the habit and culture and attitude of an engineer or a scientist. Okay, something like that. Always, because mathematics are used to prove certain scientific research and scientific theories, because numbers are measurable and quantifiable to validate your scientific research. Without numbers and math, how can you prove your theory will be correct? Something like that. Because it's not only purely statement, you need to validate that through numbers. Okay, by formulas, empirical formulas like that. That's why you have scientific law. Okay? So now, in thermodynamics, you should remember also the, okay, anyway, anyhow, if you will take mass spirals, the instructor will be teaching there what are the scientific method. So it will be like a scientific method. Okay. So will be used in your scientific research. Okay. Your scientific research will be based on your different master's topic that you're going to pursue. And you will be dealing with scientific method. Okay. What are those scientific methods? For example, you need to identify the problem. You need to identify the context, the body of the object of your content, then objective, like that, content, and then after you have the content, then you will have the data analysis there, different approaches, measurable formulas to be used to validate also your content there. Okay, after that, you will having your initial educated guess, which is the hypothesis. Okay, and after that, proving your hypothesis correct or not, you can eliminate the hypothesis which is not necessary and come up with the educated guess that is acceptable before going to your conclusion. Okay, conclusion and summary or what is it? Generalization. Okay, like that. Get the point? So, muna siya atong content sa atong scientific method. Okay. So, this scientific method, okay, here in the content, prior to the hypothesis, okay, we need to have our scientific theory. Scientific theory postulates, okay, postulates and principle or concept that is in between content going to hypothesis. Because in conclusion, we are now already having the finality of your scientific research. You don't have to prove anymore because you already concluded. Okay, so it's in your scientific theory, postulates and principles, and going to the before hypothesis, there's a lot of data, graphs, math, numbers, and formulas to use, and you can create your scientific law. Okay. So all scientists will have scientific law because this is referring to formulas, equations to prove and validate your scientific theory, postulates, principles, and concepts so that your scientific research that was concluded to be true and correct are valid. You get the point? So these are the coverage of how to become a scientist. Something like that. But normally, a lot of intelligent people have this, but it will only matter to the, resources. Resources, technology, okay, technology. These are the limitation, research limitation. Okay, technology, the state difficulty. For example, the government will not support your study, and there's no enough fund to create this scientific research, so it will not go through even though how intelligent you are. You get the point? Hindi pa lang sa resources, yabu na. Financial resources, technology, and state. The state of your country. Okay, because you need to ask support from your government in order for your scientific research to be effective. For example, I need to create an oil as my gasoline. It's possible because gasoline is a hydrocarbon. It will create mechanical energy, fuel and chemical energy to mechanical energy because through the process of combustion process or even though that is oil, not gasoline. But it takes a lot of study, support, financial resources. Okay? And then you need to take oil also for your production. How if it will yield large production and then you can have a very high financial resources. Oh, this is not practical. Things like that also. Okay, practicality, Practicality, because this practicality will refer to the impact to the community, society, and to the environment. So that you can have now your complete, what we call this one, feasibility study or thesis. And this will be taught in your masteral study. Something like that, okay? Get the point? So it's gonna be like that. Okay? That is only if your masteral study is related to science and related to engineering. But if your masterals are not also related to science and engineering, there will be also another method how to do it. Okay, for example, you're majoring in English or like that, accountancy or banking masterals like that. So it will be another also political science, okay, like that, studying foreign policies or international policies, economic policies. So it will be also another thing. This is only for pure science and engineering, for engineers and scientists, like that. Okay, you get the point. So this thermodynamics will be used. Okay. Tingnan naman ano yung kumali guys, no? Kaya almost all processes in the planet Earth involves heat siya talaga guys. Okay? You get the point? Because the meaning of heat is not meaning only hot. Cold also is a coverage of heat and that is a negative heat. Technically even in thermodynamics. That's why science matters a lot in thermodynamics as a state function. Okay, like for example, initial state and final state, ganon. Will it be going to negative, positive? And let's have a chart now to understand properly. Okay, like this. Okay. Mga palangga. Okay. This is what all I remember. Okay. Like this. So this is gonna be like this. For example, you have some two guys. Okay, mga ganon, ganon, tararat, 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 ganon. Heat, heat, ganon. Work, then energy, ganon. Okay, and then we have also enthalpy, right? Anyhow, enthalpy and gas free are all energy, delta G and delta H. Right? Hello, engineering students. Come on. Delta G and delta H, right, are all energies. Okay, like that. Now we have here, ganon. Okay, let's go to the signs. Positive and negative. Negative and positive. Like that. Ganon. Itable na lang mo siya para makasabot siya. Sige, pangita kayo. Because the question will ask for negative answer and your answer will be positive, so you will become your. Okay, like this. Heat negative. Like this. Heat negative. What's the description for this? That is heat released. Okay? Heat released. So, heat released, what do you mean by this? Heat released from, okay, heat released from the system to the surrounding. So, if that is the case, heat released from the system to the surrounding. Ang system mo na kaong giunin nyo na, isolated system, open system, closed system. Okay, like that. So, if it released heat from the system, okay, the surrounding will receive the heat. Now, it is very hot. Okay, so hotter environment. Okay, so there's no AC, there's no cooling system, so that exothermic. That's what's happening inside your internal heat engine combustion in your car. As you can touch, the radiator, it's hot, right? So that is exothermic reaction, meaning the release of heat energy is there, okay, from your gasoline. Okay, gasoline is your system, gasoline. Okay, and it will be the gasoline, then the heat will be taken out there and going to your engine, blah, 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 so and so. It will become hot, right? So heat released. Negative is heat released, meaning to say. But in the books, ano lang siya guys, heat released. It's not emphasized, released to the surrounding from the system. Ako naman siya para masabtan dun siya so that we can understand very well. So heat released from the system to the surrounding. You get the point? Or if we have the reference as our system, you will just say heat taken away from the system or heat removed away from the system because it becomes a negative in the part of the system. Right? When you remove the heat, you take away the heat from the system, then it will be negative on the part of the system because it's taken away. Okay, now it's become hot on the surrounding. Ganon. That's why negative. Okay? But the term here meaning it's on the surrounding base. Ha? And the sign meaning on the system. Get the point? Again, the negative sign is from the system because as I said earlier, it is being taken away or removed from the system. That's why negative. Now, since it's being produced or given up to the surrounding, that is heat released to the surrounding. Okay? Kasi makalimog mo siya guys, pero sige na lang. Okay, negative. Okay, and then the positive will be heat absorbed. Okay. So, the system will absorb, of course. Or it will be added to the system. That's why it's positive heat. Okay. If the positive heat is added to the system, since I said a while ago, our reference is surrounding in the statement, meaning to say, the surrounding will be cold. So that is endothermic. Okay? You get the point? So that is endothermic. Okay. Positive heat absorb, malicious endothermic. So this is very important in thermodynamics, ha? And then exothermic like this. Okay? Ganon. Nakalabot ta. So may ito sinigas, ang kanilang heat release, kanilang statement, mag-base nila siya sa surrounding. Okay? Okay, ang positive, mag-base siya sa system, ang sign. Okay? So heat, see, heat added and absorbed from the system. Okay, like that. You get out? Get the point? Ganun siya. So, you say like that. So, you can understand properly. Okay? Negative, positive heat. Now, it's related to delta H. Because heat here is we mean the Q only. The heat content, but related to delta H, which is the enthalpy change of the formation, the reaction, conversion, formation, babachu. Okay, so this is also negative, of course. Negative value and also positive value. The same thing. Okay? Like that. The same thing lang siya mga palangga. Okay, negative and positive. Okay, now delta G also negative. Negative and positive. O, ganon. Ganon. So now, we can create now, what do you call this one? Relationship of delta H and delta G. So they are directly proportional with each other. As the enthalpy change increases, the Gibbs spin energy also will increase. And the sign are the same. So binabasin ka siya, ang tema ng guess, ang kanya yung spontaneous sa delta G. Hindi na. Oh, spontaneous is a negative delta G. Meaning kasi negative sa delta heat, a delta enthalpy change of reaction. And then, spontaneous na yun. Di ba? Ang bali mo na nilang spontaneous. And then since spontaneity is independent or inversely proportional to reversibility of the process. Meaning if I will say spontaneous, that is irreversible. As in non-spontaneous also, that is reversible. So meaning to say, spontaneity or spontaneous is equals to irreversible. Non-spontaneous is equals to reversible. Meaning, the reverse. Okay? Now, you take the sign. Negative. Positive. Now, remove the spontaneous and non-spontaneous term. Yung maglibog na ka, kasi sana yung makasa spontaneous term. Yung lang siya timanan na, kung reversible, that is not spontaneous. That means positive delta H and positive delta G. Now, if you are irreversible, we need to say spontaneous. That is negative delta G and negative delta H. Ganon. Get the point? So you can say delta H greater than 0, okay, like this, is and what we call exothermic or endothermic, and that is endothermic. Okay, because positive ang heat absorbed. And then if delta H is lesser than 0, like that, so this is heat release and that is exothermic. Because if that is anything less than 0, that is negative. And it is negative heat release. So usually the book will use this one, the sign, greater than, less than, equal to 1, like that. So you need to interpret that also fairly, F-A-R-L-Y. Meaning fairly, not good, not poor. Okay, so delta H, ganon. Di ba mga palangga? Okay. Maklaro na siya, no? O, ganon na yun. Atras sa work. In the work done on the system. On. Sabi ng on the system. So that is, on the system gani guys, negative. Okay. Then, by the system, positive. Why? Because the word by, on, from, to, with are all prepositions in English. Preposition. Okay? So it matters in thermodynamics because it refers to the orientation, direction, like that. So if it is negative, meaning on the system, meaning somebody has to done the work to the system. Or other external factors that will try to do the work delivered to the system. Let's say on the system. But if you speak by, the system itself is doing the work. Okay? You get the point? The system itself is doing the work. That's positive. Which is positive because it is being added to the system itself. Okay? So, like this. So, negative work and positive work. But the unit is still kilojoules, so. And now, ano pa siya no? Napunta yung mga energy gain and energy lost. Energy gain and energy lost. Okay. Like that. What kind of energy gain? Saan mo na siya pag-compute ang energy gain? Ang energy lost. Okay? Klaro, kasya sa ato siya sa internal energy. Okay, delta E or delta U. Be careful kasi sa ubang libro uses delta U and other also books uses delta E, but it has the same meaning. Internal energy, change in internal energy. So the change in internal energy, let's say delta U lang ka, is equals to delta U final or the U final and U initial. Internal energy final minus internal energy initial is your energy gain or energy lost. If you obtain a positive value, then you say energy gain because it is positive. If you obtain a negative value of energy, that is energy lost. Because sometimes it will say only the problem, what is the energy lost of this blah 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 blah. It will never say the word internal. Okay, this is also the tricky part of especially in our course because it's not really literal sometimes and sometimes masakit yung mong brain cells. Okay, like that. What is the energy gain for this blah 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 so and so like that blah blah so. But in the heat energy also sometimes they will not put also heat. Sometimes mix up ba mix ang analysis. But try to discover lang na that is energy. That is mga energy. Dili siya heat. Ang style sa statement of the question. Di ba? Nawa mga data sheet data H. So, muna siya. So, internal energy final minus internal energy initial. Or energy final minus energy initial. So, muna ni siya. Basta di lang siya mag-ilong mga data H, chuba. Ang interference reaction. Because kung may mga data H, muna lang itong mga heat energy. Okay? Muna siya ang kung ano muna siya mga nakasakot sa mga sign ha. Okay. Nangandang ratagaan para sa problem solving. Charot. Okay. Now, naatay mga percentage efficiency. Atong klaro mo ni siya guys, na naatay mga kuan sa thermodynamics katong mga usamin to siya. Mga laws. Di ba in physics we have 3 laws of motion by Isaac Newton. Isaac Newton is the father of modern physics. And Anton Lavoisier is the father of modern chemistry. And then the father of chemical engineering is George Davis. Okay, something like sometimes it will also come out in the word examination or any quiz balls like that. Something the scientists and their contribution. Okay, like that. Blanc, who is the father of chemistry? Antoine Lavoisier. Who is the father of physics? Isaac Newton. Not necessarily have to put modern, but it's same thing. Because wala may old. Get the point? You get mo na siya mga kuan-kuan. Okay? Machu-machuchu lang na siya. Good. Okay. Ato mga Henry Becquerel, di ba? Henry Becquerel, Marie Curie, o ganon. Their contribution, James Chadwick, J.G. Thomson, Ernest Rutherford, Chadwick, okay? James Chadwick, ganon. Sila si Kuan, sila si Alexander Fleming. Wow! What is the discovery of Alexander Fleming? Based on my memorization, that is, he discovered penicillin. Okay, Alexander Fleming. Okay, who discovered the vulcanization of rubber? Goodyear. Mr. Charles Goodyear discovered the vulcanization of rubber. Mga things like that, guys, you should also memorize scientists and their contribution and maximize it. Meaning maximize it as much as you could memorize all. But since you cannot memorize all, have it more. Put that in your notebook. Exclusive for scientists. 1, 2, 3, 4, 5, 6, 7, 8. Wala siya kung mabuang sa una, guys. 6, 7, 8, ganun siya. Exclusive rin siya sa mga scientists ang usa ka notebook. Di ba nakakaloka, no? Under contribution. Who discovered oxygen? That is Jules Priestley. Mga ganon. O, diba? Who discovered the third law of thermodynamics? O, diba? That is Ernst Simon. Diba? Who discovered mga ganon the heat engine, combustion, mga ganon. So it could be Mr. Sadi Carnot. Ganon. Who discovered the ideal gas equation? It should be Clausius-Clapeyron. Okay? Things like that you should also remember. If you try to take science courses and engineering courses, particularly chemical engineering, because more on chemistry and physics. Okay? Something like that. Okay. Ganon. So going back to the equations, ganon. So we need to remember thermodynamic properties. Okay. Thermodynamic properties. And you have to explain also, after the thermodynamic properties, you have to explain also the formulas and equations. Okay. Formulas and equations. Okay, ganon. Thermodynamic properties. Saan siya mga thermodynamic properties? For example, if I will say at constant pressure, that is isobaric. Okay? At constant temperature, that is isothermal. Okay? At constant volume, that is isochoric. Okay, or isovolumetric. It's just this term. The volumetric is obvious. That's why the problem is the correct. Para maglibog ang examining, use siya ka ng term, hindi siya familiar. Okay, basta examination. Okay, so isochoric instead of isovolumetric, but it has the same meaning. Okay, when you see Q is equal to 0, that is adiabatic. Okay, meaning there's no heat exchange in your process. There's no heat involved. Adiabatic is 0Q. Okay? If 0Q, matter na dito sa delta E, ma-0 dito yung Q, may delta equal to W na lang siya. Ano ba? Okay? Dito the point. Muna siya ng buhaton. Muna siya ang thermodynamic properties. Upat ka buo. Okay. Most of siyang equivalent dito sa general chemistry lecture. At constant temperature, or kinsama na si Boyle's law. At constant volume, so muna na siya si Gay-Lussac. At constant temperature, muna si Charles law. Okay? Get the point. V1, T1 is equals to V2, T2. O gano'n. Constant pressure. Gano'n. Chuba-chuba. Na siya mga equivalent na scientist and its contribution. Okay? Most of that is sa thermodynamics. May is bullets, ceramic, gano'n. Okay? Gano'n. And then, If we have the laws in physics na katutulong kabuok, law of inertia, law of acceleration, and law of interaction, considering the gravity, we have also the laws of thermodynamics, three laws of thermodynamics. First law, four, we have zeroth law of thermodynamics, first law of thermodynamics, second law of thermodynamics, and third law of thermodynamics. Now, you need to study the applicability in each law. Because in that, you can use the appropriate equation. Ito magpataka. Okay? Because sometimes, maglibog ta because we are not categorizing during our study. And it will mix up, especially in the examination. You should have a systematized way of memorization, like that. Then, the substance is, do not just memorize, understand what you memorize. So that it's easy for you to memorize, then it will retain to your brain cells for how many years? And it will become stock knowledge and acquired knowledge. It will never be forgotten. Okay? For example, I'm memorizing the density when I was in elementary. But now, until now, I can still remember the density without referring the books, the Google search, and everything. So density is equal to mass over volume. Acceleration is equal to velocity over time. Because it's already, engraved to your brain cells. Because before you memorize, you understand what you memorized. But if you're just plainly memorizing, it will lost after 1 year, 2 years, 3 years. It will never retain to your brain cells. But if you understand what you memorize, you can still remember that until your last breath. When you die, you will still, acceleration due to gravity is 9.81 meter per second squared. Give me water! Doc, give me water. What the density of water is 62.50. Di mo makalimutan natin ka matiguang if you really understand what you memorized. Okay? Like that. Okay, the first law of zeroth law. Zeroth law is thermal equilibrium. Okay? Meaning, the temperature will be equal for the system if they are reacting with each other in a closed system. Okay? Because the system is closed, there will be no release of energy, there's no wastage, and you don't have to recover something if that is a closed system. It is totally covered without any leakages. So meaning to say, there are equilibrium there if you put substances there. Their behavior will be equal, their motion will be equal, like that, chuba-chuchu. So they transmit or they exchanging their behaviors there. So you will say substance 1, substance 2, substance 3 in a closed tank. There's no opening like this. Or in a closed container. So you will say temperature 1 is equal to temperature 2 is equal to temperature 3. Velocity 1 is equal to velocity 2, velocity 3. Like this, chuba-chuchu. Viscosity 1 is equal to viscosity 2, viscosity 3. So surface tension 1 is surface tension 2, surface 3. Specific gravity 1 is equal to specific gravity 2, specific 3. All physical properties will be equal because that is a closed system under thermal equilibrium. Okay? You get the point. So that is the first law of zeroth law. Okay, that is thermal equilibrium. So the heat transfer will be equal to each substance in a closed system. Something like that. You know what I mean, right? And then the first law is applying the chemistry principle, which is the law of conservation of energy. If we have the law of conservation of mass and law of conservation of matter, in chemistry we have also the law of conservation of energy in the first law of thermodynamics. What is that again? Okay, energy can neither be created nor can be destroyed, but it can only be transformed to various forms of energies. Not only limited to potential energy and kinetic energy, but to different energies around us. For example, chemical energy, mechanical energy, electrical energy, acoustic energy, pneumatic energy, hydraulic energy, radiation energy, like that, sound energy, like that. Okay? There's a lot of energies around us. I think there are 14 energies minimum around us. Okay, and most of the energies also have courses in it. Electrical energy, electrical engineering, focusing to more on the electrical energy. Chemical energy, focusing to that more is the chemical engineers. Okay, mechanical energy, focusing that more, the study is the mechanical engineers. So there's also equivalent. Okay, we have also electronic energies or electrons based on electronics energies. That's why we have also ACE, electronic and communication engineers. Okay, focusing on the electrons flow, electronics, like that, blah blah blah. So, kaya di pa siya matabang, imagine mas specialization. Okay, ganon. Di ba? So, muna siya ang first law. Okay, ganon. So, ang second law nga palang gawin, saan naman siya? Nakakaloka. Masa man yung second law mga palangga? Muna na siya nag-isgot ka to. Ang first law sa guys, ma-apply sa day ang kuan guys, no? Ang calorimetry principle ha? Calorimetry principle. Katong mga Q MCP dt, ganon, Q1 is equal to Q2, Q absorb is equal to Q release, ganon. Master to ninyo yung mga problem, magawa sa siya sa board examination. Heat absorb is equal to heat release, ganon, chupa-chuchu and everything. Okay, calorimetry problems is in here. Okay, the second law, including here guys, katong delta U Q plus W. Okay, ang second law guys, i-focus siya sa gives free energy. Okay, delta G is equals to delta U minus the entropy of the system times the temperature, like this. But actually, this is driven by delta S is equals to Q over T. Since this delta ST is equal to Q, that's why ang libro, the book will direct use this. Will never explain it's coming from Q. You'll research by yourself. That it's gonna be the formula of Q, that's it's become delta S times T in your second law of thermodynamics. Again, change in Gibbs free energy is equal to internal energy minus the change in entropy times the temperature. Okay? And then the unit will be joules. Okay? Kilojoules, calorie. Okay. What is our third law? Our third law is very special. It is more on statement. Okay, it states there, the third law, that for all perfectly crystalline substance, the entropy is zero at absolute zero. Like that. So statement siya more sa third law. Hindi siya applicable kay perfectly crystalline man yun siya per me ang gideal sa third law of thermodynamics. So entropy is zero for all perfectly crystalline substances. For example, kanang mga ice, okay, you know, mga crystalline substances. Okay? At absolute zero. Guys, when you mean absolute zero, guys, okay, that is not 0 degrees Celsius. Absolute zero means 0 Kelvin. That's it, a small theory, but do not take for granted. Okay? Because maybe it will come up also in the multiple choice. Blank. What is an absolute zero? Ganon. So your answer will be 0 Kelvin. Okay, because 0 degrees Celsius is the freezing point of water. That's another thing. Okay? Ganon. So, muna siya ang mga laws of thermodynamics. Atong bantayan. Okay? You get the point. And another also, I've just discovered through my research. Because I have to learn more also. Okay? If we have, for example, guys, natin 1 kilocalorie. 1 kilocalorie, gano'n siya, diba? So this is equals to 1,000 calorie, guys. Be careful, guys. The capital letter matters a lot. For example, like this. When you buy a food and there's 20 calories, take note if it is a capital letter or small letter C. Bago pa rin ako na-discover. Like, ang 1,000 calories na small letter C, calorie. This is equal to 1 kilocalorie. Nga small ang C. Okay? So in our science, the calorie there is not the big C. It's about 1 calorie is equals to 4.184 joules. Okay? 1 kilocalorie is equals to 1,000 calories. Meaning to say, the calories here, the C is small letter C. Okay? Now, if it is reflected in the food product you buy in the market, capital C, we said I have 2 calorie of kabush or 2 calorie of ding dong. If I will eat ding dong, there's 2 calories I will obtain in my dietary system. Dietary, guys. Dietary system in my internal body system, or what do you call this one? Gut. The gut health, GUT. Gut health meaning large intestine and the small intestine. Okay, gut, G-U-T. Okay. Now, first of all, I have 100 calorie, capital C, small letter A, L. This is another thing. You know the point, guys? Because this is also 100,000 calorie. Okay, if I have 1 calorie with capital C, this is 1,000 calorie with small letter C. So now, for example, if in the food beverage, there is 567 calorie, but small letter C, that is different compared to this big C. Because 1 calorie na nag-start sa capital C, equal na po siya sa 1,000 calorie na small letter C. So meaning to say, magbantay po sa appearance if we speak about calorie. And this is also the usual mistake in examination, in which I failed to detect this when I was in college. Okay? Sorry. For example, if I say 5 calorie, and then the problem put that in a statement, and it's capital C. And then the question will say, convert that to how many calories? Okay? Calories. And then that's already calories. You will say 5, right? But it is not 5 because that's big C. You should say 5 calorie capital. 1 calorie capital is equal to 1,000 calories small. cancel. That is 5,000 calories ang 1 calorie. Nga dako ang C nga naguna. Di ba dako kasi diferensya? Be careful also with the problem solving, ha? Because maybe it will give the calorie which is capital C also. Get the point? 10 calorie of, usually cal naman na siya, C-A-L, abbreviation of calorie. 5 calorie of blah blah blah. What is the energy needed to raise this substance at this particular temperature? Be careful. Kung i-present dito ang C, dako, dili na siya calorie na katong gamay nga usual na nasabtan. Ang katong 1 calorie is equal to 4.8 per joule. So this is also a technique. This is also a confusing part of phasing examination related to your science. Sa kanyang aning nga mga makalibog ng mga unit, na ganun. Diba? So, wala siya. So, tanawa po din kung iswag din siya kapital. Ice cream. If you are conscious with your diet, just like me, I'm very, very conscious. Okay? I will never eat rice. Okay? Like that. Then, if I'll say 200 calorie na capital ang C, it's not equal to 200 calorie na small letter C akong gigamit sa letter. Okay? 1 calorie ng capital C, 1,000 na siya nga calorie. So, tanawa yun ang how it is being written. If it's a big letter or a small letter, be careful also. Before you convert that to joules, to BTU, to watts, like that. Okay, BTU meaning British thermal unit. Okay, like, so diba, klaro siya guys? Wala siya, timanan ng kapatid. Diba? Laon, nakasabot pa ako sa unang. Nakakaloka. Okay, ganon. So you will prepare again. You will prepare one notebook or one logbook for all formulas and equations, one logbook for all science tests under contribution, and then one also notebook for all processes. Okay, evaporation, condensation, sublimation, filtration, flocculation, centrifugation, sedimentation, sublimation, condensation, vaporization, filtration, screening, extraction, like that. Okay, all theory in one processes only, like this. Okay, one notebook in all science tests under contribution, one notebook for all formulas and equations sa science. Nilay ko itong mga math. Okay, ang math, kung pinapumula ang math, yung gusto kong memorize yung tanan. Okay, di ba? Get the point, mga kapatid. Muna siya. Any questions so far? Ito doon lang tapo para dali kayo magtuon ba? Okay? Anyway, para-paraan raman na siya magtuon po, pero indot mo gud siya kung i-segregate nimo ba. You should segregate the same thing, categorization, like that. Okay? And then mag-master po ka sa mga chemical reaction, gano'n. Imong i-maximize ang mga different chemical reactions, gano'n. So that if it will come back, then you can answer properly. Ganun. And then mga rules and regulations. Just like the law, rules and regulations how to make a chemical reaction. Ganon. O, diba? Ganon. Thank you so much, guys, for watching this live streaming. I hope you like this, guys. You can share and comment down below in the comment section. And you can comment. And you can subscribe my right channel if you like. And then you can also click the notification bell for some newest updates of I'm singing your voice. Bye-bye, God bless everybody. Katugon na ko, guys. Oh, bye-bye. Kaloka. Diba?